Hello everybody, welcome to a new video. Today we're going to solve the climbing stairs problem on LeetCode. So imagine you are climbing a staircase. It takes n steps to reach the top, and you can either climb with one step or two steps. In how many distinct ways can you climb to the top? Let's take some example to understand the problem. Imagine if our stair has only one steps. And if you recall, we could either take one step or two steps. For this example, we will have only one possibility, is using one step to go on the stair. In case if we have two, n equals to 2, here we have two possibilities: either take one step, then another one step, or just take two steps directly. So for n equals to 2, we have two possibilities. Here for n equals to 1, we have only one possibility. Let's see now n equals to 3 and try to deduce a pattern. So here we can take only one steps, or take one step then two steps, or start with two steps and finish with one step. So for this case we have three possibilities. For n equals to 4, we can take ones all the way to the top, or we could take ones at the beginning, then twos, then two steps. We could take two at the beginning and the ones at the end. We could also take two and two. I think I missed something. Yes, and the last one, we could take the two steps at the middle. So here in our case we have 5 possibilities. So as you can see, we have 1, 2, 3, 5. 1 plus 2 is 3, 3 plus 2 is 5. So here it's the Fibonacci numbers. Can we actually prove that? So imagine we have stairs, and this is n, this is n minus 1, and this is n minus 2. Imagine we know the number of possibilities for n minus 1. I'm going to call it Pn minus 1, and we know the possibility for for n minus 2. So basically, to calculate p to n, so either we take all the possibilities of n minus 2 and we add to it 2 steps. So for example, if we had for n minus 2 all of this, so to attain the nth step, we're just going to add 2's. Okay, and so here we calculated the number of possibilities from n minus 2. That's why we will need Pn minus 2. And to arrive to the nth step from n minus 1, we will need to add ones. For example, if we had this, or I don't know, this, for n minus 1, we're just going to add ones here. So that's why we need to add Pn minus 1. Imagine if we could have taken 3 steps, 2 steps and 1 steps, and we had here n minus 3. So we either can start from here and take 3 steps, or start from here and take 2 steps, or start from here and take 1 step. So we will have here Pn minus 3 here too. So basically the idea is that in order to arrive to n, I need to either be at n minus 1 or n minus 2. And if I know the number of possibilities to arrive to n minus 2, that's great, because then I can add it to the number of possibilities of n minus 1 to get finally my number of possibilities in P the n, P of n. Okay, so this is Fibonacci, and you know Fibonacci, if we use the recursive method, it's going to be 2O of 2n. So it's exponential. So let's start to code it actually. So it's pretty simple. If we have n is less than or equal to 2, just return n. In our case, if n equals to 1, we're going to return 1. If n equals to 2, we're going to return 2. And then we return climb stairs n minus 1 and plus climb stairs n minus 2. If I run the code, it's correct. Can I add like 5, 3, 4, run the code? It's gonna take a bit of time, okay, but it works. So it's right. We could actually improve this code by using what we call memoization. Because when I'm trying to calculate a Fibonacci number, for example 5, I need to calculate, first of all, the Fibonacci of 4 and 3. Then I need to calculate the Fibonacci of 2, of 3 and 2, and so on. Here I need the Fibonacci of 2 and 1. And here we've arrived to initial state, so we can return their number directly. Initial state, okay, and 1. So here the Fibonacci of this is 2, and this is 1. I can add them, so this is 3. This is 2, so I can, this is 5. And same thing here, 2, 1, 2 plus 1 is 3, and 3 plus 5, 8. Here, this is the indices, okay? And this is the value, okay? And as you can see, there are a lot of values that are calculated so many times. For example, this has been calculated 2 times, okay? So we can avoid this by having a memo. A memo, it could be an array, a hash, map, or a set, depends, okay? So every time we calculate a value of a Fibonacci, we're just going to add it to our memo. And then when we arrive to the next value, for example this, first of all we're going to check the memo. If it exists, we're going to use it. And if it's not, if it doesn't, well, we have to calculate it anyways, okay? So let's try to add this memo in our program. For my case, I'm going to use an array, new int of, okay, I'm not going to use an array actually, I'm going to use a hash map. So hash map of integers called memo, so new hash map. Okay. Why a hash map? So the key will hold the index, okay, and the value will hold the actual value of the Fibonacci number, okay? So yeah, so if you are in the initial indices, we just return. If not, we check if in the memo we have the n, and if we have the n contains key n, and if it contains the key, we just return memo dot get value n. And if it's not the case, we put into our memo. Well, first of all, I'm going to create a variable to hold my value. So result is going to equal to climb stairs. So I can remove this. Okay, and then put this result. I can return the result, but before that I can put the result into the hash map. Now let's try, hopefully it works. Yes, it does. Let's submit it. 0 milliseconds. Okay, cool. So the actual time complexity here would be O of n, okay? But also the space complexity would be O of n. Thank you for watching. See you in the next video.